Okay. So, find out law of sine is not so straightforward now. Okay. So we need a ruler and a protractor to do this. So what we're gonna do is we're gonna how do I write this in here? I didn't have this in here. So obtuse triangle. It means there's an angle. That's angle. Well, maybe I better write that out. Looks like it. There's an angle greater than 100 or 90 degrees. Where I got it from? Acute, all the angles were less than 90. And then the right triangle has the 90 degrees, right? Those are the different ones. Okay. So we're going to just try drawing this triangle given the information that they gave us. So I just need a reference line, so I'm just going to draw a line so I can use my protractor to draw 30 degrees. So I need a line to start with, so I'm just going to draw a line. Okay, now I need to draw 30 degrees, so I'm going to take my protractor, I'm going to put it at the end of one line, and I need to tick off 30 degrees. Don't make too long of a tick because then it'll be too long, so just a little spot right there. 30 degrees. Everybody see how I did that? Okay. And we know that what we draw here is right here. I need to label this what? What is that right there? I drew the 30 degrees here, so this is A here, right? So I'm going to just call this side B. It's somewhere over here. I don't know actually where it's going to end at some point, so I'm just going to write B over here somewhere. But it says that side B is 5 centimeters. So I'm going to make this side B. I could have made the other side B, it doesn't matter, but I'm going to make it this side for. Okay, let's make it easier. So, or I could have made this, like I made this side B, or this side B, but not this side, because what side is this? A, right? So I need to go in the corner there and draw up to 5 centimeters in length. It should actually be at the very end of your little tick almost, because the protractor at that distance, it's 5 centimeters apparently. Okay, so there's my 5 centimeters. Now I'm going to draw side A, which is what? How long is side A? 3.5 centimeters. So I know side A is in here. I just need to put this at the end, and I need to move my, my ruler till I have 3.5, and I hit this other line, right? Like that. I'll be a little bit off there. Okay, so there's 3.5. Okay, is that the only triangle I can make? I could actually turn this way and get 3.5 as well. Use a different color. Right about there. So I'll just call this B prime. Oh, I guess I should close that. Okay. And we'll call this C here. So the problem with this situation is you don't know when you're giving it to you like this, right? We don't have a picture or anything, right? We don't know if it's the purple line or the green line. We don't know which one it is. It's what we call ambiguous, meaning it's not clear. Okay, so there are two possible triangles that could happen here, and we just physically made them. So we get two triangles. This one, ACB, is acute. Meaning it doesn't have more than 90 degrees. But you can see angle B, that's more than 90, right? Right here. B prime. Yeah. But where you have triangle AB prime C, it's what we call obtuse. That's an obtuse triangle.
What is their prime in front of C?
No, it's after the B. Goes with this one.
Oh, so it's two B's. Oh, okay.
Yeah. Your side B or your angle B could be here or it could be here.
Okay.
We don't know which one it is because they didn't. But given the information like that, we don't have a picture. We can't tell which one it should be. Now, if we use the law of sines, what answer are they going to give us? I'm just going to erase this now. It's over here. Is it going to give us this angle? Or is it going to give us this angle? It's only going to give us one. And from the earlier video, which one did it default to? You're the one that saw it. Did it give it, when the earlier video, did it give us the big angle or the smaller angle? Yeah, it's going to give us, law of sines we'll find when we punch in the numbers, it's going to give us, it's going to assume acute triangle. That's what it assumes. And so we'll just do that. Oh yeah, and I forgot to write in here, we know that this is 30 degrees because we drew it that way, right? Okay, so we know a side angle pair, right? So we know 3.5 over sine of 30 degrees is equal to, and we want angle B. So we have side B, which is 5 centimeters, and we want sine of B. And you do the math, you basically end up, right, timesing, divide. So that's going to equal sine 30 times 5 divided by 3.5. And what do you get when you do that? Sine of B equals, yeah, 285. Da, da, da. Now do your inverse sine, and you get what? So we'll say 45.6, just round it off. Yeah? So B could be this. I'll write it in there. Right? How can we figure out this angle? What do I have right here? These two sides are the same.
So that would mean that the other side would be 45.6. And
Yeah.
take 180 minus
Right,
45.
exactly. I have an isosceles triangle. This equals 180. So B prime is going to equal 180. minus 45.6 degrees.
And 34.4?
Yeah. So the law of sines will only give you the acute angle. But depending on your problem or situation or the diagram that you're looking at, you may need to do this step because it may be this angle. Because we don't know if the triangle's like this or like this. So there's two possible answers. Or it may be we know it's this, but when we do the math it gives us this, therefore we need to subtract to get the other one. I'm going to just write some of that down. So you need to consider both possibilities. Okay, now we're just going to look at another situation. We're going to consider when B is longer than A. Or when A is longer. I should say that the other way around, I think. Yes. Consider when side A is longer than side B. No, that's what's happened there. Okay. So we're going to draw the same thing. We're going to just draw a line, kind of a reference line, so I can draw my 30 degrees. Take your protractor, draw your 30 degrees. I know this is A, and I'm going to make this B. So this is my side B here, which is still 5 centimeters. So I'm just going to draw that out. I know this is 30 degrees in here. Now my side A is 6 centimeters. Did I draw that long enough? Yes, I did. Okay, so this...
Sorry.
So A was 6, right? B was 5. A is equal to 6 centimeters. Can I draw another triangle? If I move this around, can I hit that line again? Can I draw another triangle? No. Because this is longer, I can't. It's only one triangle. And it's the acute one. So we don't have to worry about, just use law of sines as normal. Use. You can only get an acute triangle. That's the only thing you can get. But, so we don't need to worry about finding this, but what I want to do is just, how do you find the height of a triangle? How can we do that? What is the height of a triangle? Where do I measure the height of the triangle?
In the middle.
Like from the peak to the base? Yeah. So I can draw, this is the height. Right there. And this has to be perpendicular, so these are right angles. So how could I find that height? I know this angle.
Base.
What's this to this angle?
Opposite.
Yeah, here we have opposite. And what's this in the triangle? This right triangle, what is it?
That's hypotenuse.
Hypotenuse. What uses opposite and hypotenuse?
Sine.
Sine. I'm just going to write this up. Maybe I should write that out. And he's going to use a trig ratio. Usually ends up being sine. So sine of 30, this is where I'm looking from, is going to equal my opposite, which is h, over my hypotenuse, which is 5. So basically end up doing that. So sine of 30 times 5 equals, ends up being 2.5 centimeters. So if side A was 2.5 centimeters, you would have a right triangle, because it would hit right up and down here, right? If it was less than 2.5 centimeters, would you even get a triangle forming? Do you think? If I had 2.5 on here, am I ever going to hit, it's right here? Or, sorry, less than 2, no, so let's say 2 centimeters. If I have less than 2 centimeters, or 2.5 centimeters, I can't get it to connect with this line. It's what we call it, it's impossible. And that's when you'll get a sign or any trig, like one of the trig decimals is greater than 1, and then it's an error, like can't happen, it's not working, that type of thing. It means the triangle is impossible. You can't make it. So that side's too small. So that's what's actually on the next side there. So Linda, have you look at it when it's is that triangle in front of you. So here's the situations we're looking at here. Okay, so here, A is greater than H. It gets greater than the height. But A is less than B. Right? A is shorter than B. And that's when you get that ambiguous case. We don't know, okay, does it go this way or does it go that way? We don't know. So you have to consider both possibilities and what's actually in the situation that we're looking at. So this gives you ambiguous. What's happened here? A is equal to H, to the height. Write it like that if you want. And you end up with a right triangle. And then here, this is when A is less than H, and you can't get a triangle formed. This can't happen. So if we do this in the calculator, watch, if you do like, so let's say I said from our last example, we said this was equal to 2 centimeters, right? And we'll say this was 5 and this was 30. Just using our last example. We set up the sine ratio. You have 2 over sine of 30, because this is the opposite side. You agree with that? I mean, it doesn't go all the way, but that's the opposite side, right? That's the side pair, A with A, which equals 5 over sine of B. Now do the math in your calculator. Times this, divide by that. So you have sine 30 times 5 divided by 2. What do you get?
1.25.
Yeah. You get 1.25. Remember when I drew that graph the other day? You can only be between 1 and -1 for cosine and tan. Okay? So, and then when you do the sine inverse of 1.25, it says error, meaning angle B doesn't exist, because it doesn't. There's nothing there, is there? Yeah. So if you're getting that, it might be because you're in this situation. Or it could be you just made a mistake somewhere. Okay, so how to determine if there's an ambiguous case. You could find the height of the triangle. That's not always necessary, using a trig ratio. If the side opposite the given angle is more than the height, so that's side A, we're always referring to that as side A, but less than the other given side, which is B, you have an ambiguous case. So you have this. If A is less than the height, it's an impossible situation. It's just, it doesn't happen. It's nothing. Okay? So that can be rather confusing sometimes. But one way I look at it, when we had it, we have the angle given. So here's my angle given. Right? And the triangle may not be labeled nicely, this side B and that side A, and you know, so we're going to try and make it different. So it can be applied anywhere. So here's your angle given. What is B to this angle? What's a word we could give that? That's like a trig ratio one with the right angle, but triangle, but we'll use it here as well. What is A to B here? This angle, what would we call that side? Adjacent. It's adjacent to angle A. And angle A to side A, those are what we call? What would this be to this angle? Opposite. And that always, when you have the same letters, they're opposite, because that's how you label a triangle. This is opposite. So basically, if your opposite side is less than your adjacent side, that will equal ambiguous. As long as this is longer than the height. You know, it's got to be bigger than the height. Opposite has to be greater than height. So that will give us a case where there might be two triangles forming and we don't know which one it is. All right, so let's look at this problem. So, Martina and Carl are part of a team that is studying weather patterns. The team is about to launch a weather balloon to collect data. Martina's rope is 7.8 meters long and makes an angle of 36 degrees with the ground. Carl's rope is 5.9 meters long. Assuming that Martina and Carl form a triangle in the vertical plane with the weather balloon, I don't see why they wouldn't. What is the distance between Martina and Carl to the nearest meter? So we got to kind of draw that out. So let's use M for Martina, C for Carl, that's another angle, and how about B for balloon? Or a weather balloon. So I have, and this we can just draw, we don't have to use a protractor, we can just draw it, sketch it out. I was just using the protractor to prove a point last time. So let's say Martina's here. And I know she has a rope. I know she is, this is 36 degrees. Here's the ground. Martina's here and, well, she's up here, I guess, but how long is her rope? And that goes to be the balloon. 7.8. So that's Martina's balloon. Okay. Let me make this a little bit longer. And then I know Carl, he'll be over here, maybe. I don't know for sure. We know that his rope is what? So this is 5.9 meters. So from what we did up above, I'll move this down. This was the angle given, right? So I'm looking over here. Here's my adjacent side. Here's my opposite side. I'll just write opposite here, adjacent. My opposite is less than my adjacent. Does that make it ambiguous? Yes. This rope could be like this then. Try and draw it about the same length, because it is the same length, but oh, I didn't quite do it, but anyhow, 5.9 meters. So I guess I'll just call that C prime for, I don't know where Carl is. Is he over here or is he over here? And the ropes are kind of going like this, or are they going like this? We don't know. So what we want to find is this. That's what they're asking us to find. Length of side B. Now I don't know if it's here or here. Right? I don't know which one it is. So I got to consider both possibilities. So I can use law of sines. Now I got this side angle pair. And I could find angle C, right? Because I got this pair. And then I could subtract, find angle B. And then I could find B, the side of length of side B. I don't have enough information to just find B right away. Can you see that? I have this pair, I can use that. I can find this. I can't use law of cosines because I don't have side angle side. I don't have that. Can't use it. I have to use law of sines. It's the only thing I can use. Okay. So remember, what's law of sines going to solve for though? Which angle? This one or this one? C or C prime? C. It's going to solve for this one. It always defaults to that one. So we will use law of sines, and it'll be for this acute triangle. This is so I can find angle B and then side B. I have to find C to find B. So, I got this pair, 5.9 over sine 36 equals 7.8 over sine C. Find the answer. What does that end up equaling at the very end of it all? How many degrees?
Uh, 60 degrees or 50.99.
Is that what you got?
50.99.
Yeah, 50. Is that what you got?
Yeah.
Oh,
Or 61.
That's what confused me.
60 and then
So we'll say 51 degrees.
Yeah.
We'll round it.
61 over 50.
We'll round it to 51.
51, yeah.
Okay.
Oh my god.
That's okay.
I said that.
I was just confused. That's all.
I confused myself too.
it's stuffed up in the head.
Yeah, exactly.
Okay, so we got that. Now that's here, right? And that, I can get this big angle B. So angle, should maybe specify which one it is. Angle AMBC is going to equal 180 minus what? $51, and what else?
36.
36. And it's that the big angle. And what do you get when you do that? 93 degrees. And now, so now that I have this, I can solve for my side B. And that's where they're further distance apart. So I can still use law of sines. I have 5.9 over sine of 36 equals, now I know my angle. So B is my question mark, right? Over sine of 93, and you get the answer of what?
10.02.
Okay, but there's a big but. We have to consider the other triangle. We don't know that. So they could be 10 meters apart or it could be closer. How are we going to do that one? How can I find this angle?
Go 51 minus 180.
Yeah, because we know this is 51 too, right? So I can find angle MC prime B, we'll say, is going to equal 180 minus 51. Which equals 129 degrees. And now I need to find what that is for angle B. Because this angle's bigger, now B's a lot smaller, right? So therefore angle MBC prime is going to equal, we have our triangle here, what? 180 minus what?
129.36.
Yeah. And you get 15 degrees. So now that's what's in here. I'm just going to draw it here. So now we can use law of sines using the 15 degrees. So side B is going to equal 5.9 divided by what? Sine of what? 36 equals B over sine of 15. Do the math. And you get what for an answer? To the nearest meter. So it's 2.59 something, right?
Yeah.
To the nearest meter, that would be how many meters? 3. So they could be this, or they could be this. Any questions on that one? It's a lot of work for one question, eh? But that's usually real life. Okay, so that was ambiguous. Here's another example. Alright, these guys are hiking, and they left the car in the parking lot, and they walk in a northwest direction for 12.4 kilometers to a campsite. Then they turn due south and walk another 7 kilometers to a glacier lake. The weather is taking a turn for the worse, so they decide to plot a course directly back to the parking lot. Carrie remembered that from the parking lot map, that the path to the campsite and the path to the glacier was about 30 degrees. So between the two paths, she saw what the degrees were between that. What compass direction should they follow to return to the parking lot? This is something you might need to use if you're, I don't know, hiking. Okay.
Just tell them turning what degree I'm turning. Yeah, like that. Yeah.
All right. So we kind of got to draw a picture so we know what we're doing here. And whenever you have directions, you want to kind of draw those little crosshairs just to kind of give you a general. So I'm just going to, I know I'm going northwest, so I got to leave some room over here. So let's say I just draw this here. Here's my, and northwest is generally this way. In this question, they don't mean exactly northwest. It's the way they had it in the textbook. I wasn't quite happy with the way they worded that, but okay. So northwest generally in this way, and they get to a campsite. So it's good to label this. This is the parking lot. Label it backwards. Okay. And they hiked 12.4 kilometers. Right? From the parking lot to the campsite. Does that make sense? Then what they do?
Turn south.
Mm-hmm.
Another 7 kilometers to Glacier Lake.
So I'm saying this way's north, right? Which is normal. Due south would be straight down, right? And the main thing here is they went shorter south than they did here, right? So make sure you draw your line shorter to some degree, right? You don't want to draw it longer because then it'll visually make you see something that isn't there. So you want to kind of have it somewhat in proportion. It doesn't have to be to exact scale, but you want to, so we'll say 7 kilometers to this lake. To the lake. So this is where they are now. And whenever you're returning back, it's a good idea, okay, where am I now? Just so I know. Okay? So their current position is right here. I got too many C's in there. There we go. And she happened to remember when she looked at the map, there was 2 paths, one to the campsite and one to Glacier Lake, and between those 2 paths was 30 degrees. So she knew that the path to the parking lot from the lake, right here, was 30 degrees right there. The nice things about giving the directions, I know it's not ambiguous. It's what It is. This is an obtuse triangle though. Okay, I know that the acute triangle is not going to come into play. I know I need to use what the obtuse triangle is going to give me.
See, the way I took it from when I read it, wouldn't have been the parking lot that was 30 degrees, it would have been at the campsite was 30 degrees.
No, listen to what it says. Carrie remembered from the parking lot map that the path to the campsite, so from the parking lot so here's the map, you are here. So they're looking at the map at the campsite, or at the parking lot, okay? So the map is depicting from you being at the parking lot, okay? That the path to the campsite and the path to the lake was about 30 degrees. So they're comparing the two lines where the angle forms. That's the way most of the questions are written like that too.
That's why because I took it from, like I said, the campsite, that degree was the 30 degrees.
Yeah, see, it's
But it says from the parking lot map.
But from the map, it doesn't mean, it's just the way I took it, but, okay.
That's what I'm probably gonna scrimp on that.
The path to the campsite.
Because you have the map.
It's not says to, it's and. So it's between the path to the campsite and the path to the lake.
Okay, yeah,
It doesn't say to, or it says between those two paths. Because you gotta have two lines to form an angle. Yeah. 30 degrees. Okay. So, I'm just gonna write out kind of, since directions are given, you kind of know the situation. And it's not ambiguous in the sense and you need to use the obtuse triangle. So you have to use it as obtuse. So the law of signs is going to give you some not obtuse. It's going to give you acute. So we're going to have to, make sure that we find the supplementary angle. So we can use law of signs because we have a side angle pair. And we can find this angles which we want to know the direction, right? We're here and I gotta know the angle in here so I can get a direction from it. So that's what I want to find, is this angle right here. So I'm gonna call this angle that, just so I have a name for it. So 7 over sine of 30 is equal to 12.4 over sine of theta. You do the math and you get what for the theta? Okay, but that's for an acute triangle. When you look at that, that's more than 90 degrees. So it ain't 60. So what do I have to do with that?
That minus 180.
Mm-hmm. This will write it down here. And when you do that, you get what, 117. Writing too many sevens there. We'll say that's 118. So I know this whole angle is about 118. But how do I get a direction out of that? Draw another crosshairs in here. How do I get a direction out of that one?
So it's south 118 degrees east.
No. You usually don't go over 90, but when you do that. It's kind of, you can't really use it, but I could use this direction in here. What would this angle in here be?
Whatever, 18 minus 48.
Yeah, it was going to give us the 62, yeah. So I'm just going to write that down. So this is the angle in the triangle, not a direction. Right? But if I do 180 minus the 118, I get the 62 degrees. How can I write a direction from that? Where am I starting here? South. So I'm starting south, right? South, and I'm moving what? How many degrees? 62 degrees to the east. Yeah.
Actually, by doing the sim, you could have said use that degree right there, which gives
You could, but it's not the degree in the triangle that you're using. Yeah.
Degree of directionality you need to go.
Yeah. But it may not in another case. Yeah. So don't skip to that. Okay. Or how else could I write that? What's in here?
East degree.
Yeah, but how do I find a degree? What would it be?
90 minus 62 should be 28.
Yeah. Or I could write east 28 degrees south. You write out the question. That questions 1 to 4. Oh, question 3. No, 1 to 4 is fine. Question 3. Oh, need the book. So just from that video, you missed the video that we watched, Jordan.
A little bit we got to see of it.
Hmm?
The little bit we got
Yeah,
to
but
see.
it just is, all you do, if you find this, so I'll do the first one. So if you put in sine 6.64, okay, that will give you the acute angle that goes with it, which is oh sorry, I keep forgetting to do inverse sine. Inverse sine 0.64. So that's 29, we'll say 40 degrees. Okay. What other angle will it also be? Do you remember? That will give you that same 0.64. What do you do? What did they do in the table? What are they doing here? $180 minus 40. Yeah, 140. Now if I do sine of that, yeah, because I rounded off, it won't be exact. 0.64 again. So the supplementary angle will give you the same sine ratio. So once you find the angle, all you do is subtract it from 180. And that'll give you the other angle that will have the same value as this. What do you do with this one? What's that number as a decimal?
Which one are you putting it?
Right there. What's 1/3? Yeah. How are you going to find that one? Just divide, get the decimal. No. Divide. There's your decimal. And then do the inverse sine of it. And that's it for trig. They had to add this into it. Didn't have to teach this before. Ambiguous case.
Is that new or?
It's new as of 2 years ago.
Why do you even put it in there? It's pointless.
No, it's not. Just means it may not be, what you're doing may not be the only answer. You need to know that if you're doing construction.
I'm not doing
Construction.
What?
I'm not doing anything in construction.
Oh, you never know when it might come in handy.
I might need to know it.
I doubt I'll ever need trigonometry in my life, so for what I want to do, so.
If you get lost, it might come in handy.
And if I get lost, I just panic and my parents.
You know, that's what the apps on the phones for.
Yeah, exactly. It's okay.
They'll tell me how to
Not
get
if
out.
there's
Yeah.
not if there's no service or your phone's dead.
That's what we needed it.
So we're gonna take a break whenever. We do go till 4. It's up to you guys whether you stay or not.
I'm about to pick me up, so I'm going to transport the sale for
There you go. So when are they doing the ad?
Monday we're gonna go record it.
Really, that quick?
Yeah.
So she wrote a script out, or is gonna write one out?
She's gonna email it to me.
Oh, okay.
She said by the end of the day she should email it to me. It's only gonna be like a couple sentences.
And then, what, is she taking some of your ideas, or
I guess.
what, did she just ask you what school was like here, or what?
Yeah. What school was like and come back. She talked, rambled for a little while, and she said she's gonna come up with a couple of questions. It's like, maybe I should have watched what I said.
My, I hope you said good things.
All bad, all bad. You might not want to listen to it.
Oh, I guess I can stop recording.